I'm going to be talking about replica types, a new feature added in Solar 7, and in particular, how they can be used to achieve what before SolrCloud was called master-slave architecture. My name is Tomás Fernández Löbbe. I'm a software engineer at Apple. I'm also a committer and PMC member at Lucene Solar project. This is going to be the talk. Have any of you been to the previous replica types talk? Okay, so there's going to be some overlap. So the idea of my talk is to guide it to one of the main use cases that I think drove the replica types, which is supporting a master-slave architecture in SolrCloud. There will be some overlap with that talk. Hopefully, you still get enough new information with mine. So yeah, I'm going to start by talking about how scaling was before 4.0, because I continuously talk about master-slave, right? And then how SolrCloud changed that, what that implied. Then mention some of the reasons why we decided to add replica types. And then go to to what replica types are, which ones we added, what they do, what they can't do, and then how you can do master-slave. It's going to be pretty trivial once you know all that, but then we're going to talk about that, and then how to use them and to-dos. So yeah, before Solar 4, before SolrCloud was there, the way to scale Solar was to do a master-slave architecture, where essentially all the updates would go to a master node, and all the queries would go to one or more slave nodes. And the way the slave would get the new documents would be by doing a segment replication, okay? Periodically replicating from the master. So I'm already talking about segments. I'm guessing most of you already know what they are, but just in case. So everyone knows Solar is built on top of Apache Lucene. Lucene stores its index in segments on disk. Those segments are pieces of index, essentially a subset of the documents that were added to Lucene. And as you keep adding documents, either when you could do a commit, or when you do an open searcher, or when the memory buffer fills, Lucene will flash a new segment to disk. An important thing is that those segments, once they are written, they never change. So Lucene never changed an existing segment on disk. Okay? What there is a background thread that will go and choose segments and choose how to merge them and create new ones with all the data that they have, and then delete the old ones. So yeah, back to segment replication. The way it works is that the slave server will go and ask the master, which segments do you have? In this case, the master is going to respond, okay, I have segment 1, segment 2, and segment 3. And the slave is going to say, okay, I already have segment 1 and 2. I don't need those. Give me segment 3. It's going to copy the new segment and open a new searcher, and those documents will be available for search. This strategy does not support near real-time, does not support soft commits, okay? One of the issues with this strategy is that there's no high availability of writes. So if you have this architecture and the master server goes down, updates cannot go through. The good thing is that the queries still work, but you don't have any updates, right? So Solar 4 came with it, SolrCloud. SolrCloud is the set of capabilities that allow Solar to have high availability, distributed indexing, automatic load balancing, all those things that we want in Solar. One of the main features that came with SolrCloud was distributed indexing. So this changes the way the documents are shared across replicas of a shard. Oh, and by the way, most of the talk I'm going to be showing like those diagrams. Think for now of single collection, single shards, because it's easier to see that way. All the concepts apply to multi-shards, multi-collections also, of course. So I was saying, So we change how updates are added by using distributed indexing. Now the way it works is that when the user sends a document to Solar, it will go to the leader, either directly by the user, or if the document is sent to any other node, that other node is going to forward that request to the leader. The leader is going to add the document locally, version it, and then is going to, in parallel, send that document to all the replicas of the shard. Those replicas will respond. Will add that document locally and respond to the leader. Once that happens, the leader acknowledges the update. We have your document. Another big feature of SolrCloud was the transaction log. The transaction log essentially holds the documents that were added after the last commit was made. Okay? It's not a Lucene file. This is a Solar file. And it is needed for recovery in SolrCloud, and it's also needed for real-time get. So I'm already talking about recovery. Let's explain what it is just in case. As I was saying, this is the way distributed indexing works. But let's think on this situation where the replica 2, for whatever reason, couldn't respond to the request. For example, it was either doing garbage collection, or there was a network problem, or something like that. Replica 2 did not acknowledge the update to the leader. What is going to happen now is that Replica 1 will continue a document, respond to the leader. The leader is going to tell the Replica 2 to recover, okay? And it's going to acknowledge the update. We have your document, but now Replica 2 is on recovery. So that replica cannot serve search traffic because it's missing data. So it needs to recover, okay? The recovery is going to the replica, also going to Zookeeper. The idea is that that replica cannot serve any search traffic anymore. So it will need to recover. This is a very high explanation, a high-level explanation of how recovery works. There's some more deep talks about how recovery works if you are interested in that. So the replica will start buffering new updates, and it will try the first thing, that's the peer sync. In the peer sync, the replica will ask the leader, which documents do you have? Which documents did I miss? This is the last one I have. Which ones do you have? If the number of documents that are missing are not too many, let's say the default is 100, it's less than 100, then the peer sync will peer sync will succeed, right? Because the replica is going to say, okay, send me those X number of documents that I missed. It will update locally, and done. Replay the buffer, and that replica is active, okay? But if that doesn't happen, because the replica is behind by more than those 100 documents, or whatever your configuration is, it's going to proceed and do a segment replication. The exact same segment replication that would happen before in master-slave, right? So it will do a commit on the leader. It's going to start doing replication, download all the segments. So, okay, with this, if this all works, why do we need replica types, right? So there are some features or capabilities that we lost when going from master-slave to SolrCloud. One of them is that that separation of responsibilities that master-slave has, right? In master-slave, because all the updates go to the masters and the queries go to the slave, an expensive query cannot change the indexing throughput. And also, if you have a very expensive update or too many updates, it cannot change it doesn't affect the query latency or throughput, right? In SolrCloud, this doesn't happen because every replica is doing everything. It's doing updates and it's doing queries. Another case for the replica types is that one of the great things about the distributed indexing is that it allows us to do near real time, to do soft commits. But for some people, that's not so important, and they prefer to have availability of search, even if it means serving data that's older, right? I prefer to respond with a document that has old data, maybe hours or minutes or whatever your time is, instead of saying, I'm a replica, I'm in recovery, I cannot respond, right? Leader-initiated recovery, which is that recovery I was talking before, can be a problem for those cases. Also for big clusters, it can be wasteful that every replica needs to do all the work, needs to do updates, needs to do commits, needs to do merge. When you have a 3-node cluster, you may be okay with that because you want the high availability of writes, you want the documents everywhere. But maybe if you have a 50-node cluster, you may not need all replicas to be doing everything. Also, I talk about recovery and how it has those two phases. But in practice, and especially in cases with high update throughput, the chances of the piercing succeeding are low. Because the replica can be out for 1-2 seconds, and that may be already the 100 documents that you the maximum documents that the piercing can get. So it will go immediately to the segment replication, and the segment replication in SolrCloud has a problem. Remember how when I was talking about segment replication at the beginning of the talk, I was saying that the slave will ask the master which segments do you have. I have 1, 2, 3. Okay, I just need 3. It's incremental in that sense. For the most part, it's incremental. But in SolrCloud, there's a problem because every replica is doing updates. Every replica is doing commits. Every replica is doing mergers. So the segments that one replica has are completely different than the segment that the other replica has. So that segment replication is very unlikely, almost impossible to be incremental, right? So let's go on this example. Let's say we have those 3 nodes, node A, B, and C. A is the leader, B is an active node, and C is in recovery. So C, what I was saying, like B has segments B1, B2, B3, A has A1, A2, and C has segment C1, but still in recovery. So let's assume piercing failed, so it needs to recover. So segment node C is going to go and say, hey, leader, which segments do you have? I have 1 and 2. I have C1. Yeah, you don't need C1. Just get A1 and A2. Okay, so it downloads the full index, right? Okay, node C, you recovered. Now it's active. Let's say time passes. Node C is not very reliable, so it goes to recovery again. And now we have, there was a change in leadership. Now the leader is node B, okay? And node B has a completely different set of segments than node A. So if it needs to recover, node C is going to say, hey, I need to recover. Okay, which segments do you have? I have segment B1, B2, and B3. Okay, I have A1 and A2. Yeah, you don't need those. Throw those away. Download B1, B2, and B3. So it again downloads the full index, right? So yeah, to solve those problems, we added replica types. 3 types of replicas. NRT, that stands for near real time. TLOG, that stands for transaction log, and pool, I guess because it pulls indices. Sorry about the naming. Actually, this was the tough part, decide the names that we wanted to use. If you look at the Jira for this, there's a lot of iterations on the naming. This is the best we could get. So yeah, what do they do? Near real-time replica is exactly the same. It's not a new type. It's essentially the name that we gave to the old replica types, right? So what I was saying before, the user adds a document, the leader gets it. Let's, for now, don't think what type of replica the leader is. Let's just think about the replica in the right. So the leader will index locally. It will update its transaction log, and then it will send the document to all the replicas, all the followers in that shard, right? The replica will index locally, update the transaction log, respond to the leader, and the leader will acknowledge the update to the user. So this type of replica supports everything that SolrCloud supports until now. It supports near real-time with soft commits. It supports real-time get. Any replica that's near real-time can become a leader. Yeah, so again, this is the type of replica that exists. It's not a new type. One of the new types that we added is the TLOG replica. Essentially, the way it works is when the leader gets the document, it will send it to the TLOG replica. But in this case, the TLOG replica is only going to update the transaction log. It's not going to update the index. And it will acknowledge, okay, I have the document. And what it's going to do is periodically replicate, the same way that the slave was doing before. Is going to do a segment replication from the leader, okay? TLOG replicas don't support soft commits then, because you have a question? For now, let's not think about the type. The question was what type of replica the leader is. For now, let's just not think about it. I'll come back to this in a minute. So I was saying the TLOG replica will not support near real time with soft commits. It will not support real-time gets, and I will get to that. Okay, and then the third type added is pool replicas. So pool replicas behave pretty differently than the current replicas. So when the leader gets the update, it won't even send the document to the pool replica. It will acknowledge to the user. It will send the documents to whatever near real-time or pool replicas are there in the cluster, but it will not send it to the pool replica. The only thing the pool replica is going to do is replicate. This is the replication that the TLOG replica does. This is the replication that the master slave does. Okay. For this reason, also the pool replica will not support near real-time with soft commits. It will not support real-time get. And so why do we need pool replicas then? So the main reason, one of the main reasons I think that the pool replicas are interesting is that they cannot go to leader-initiated recovery, right? So because it doesn't get the update from the leader, it will never go into a leader-initiated recovery state. And they will continue serving traffic as long as they can talk with Zookeeper, right? You can still query, even if there is a partition and it cannot talk with the leader. So that will give you some out-of-date data, the same as if master-slave, the slave cannot talk with the master. But maybe that's what you want, right? So let's go through a summary of what they do, because I know it's pretty complex. So the near real-time replica, that's the type that exists today. It will index, it will update the transaction log, it will receive always every update, and it will not replicate periodically. The transaction log replica is not going to write to the index, and there's a star here. It's going to update the transaction log. It's going to receive every update, and it's going to replicate periodically. So what do I mean with it doesn't write to the index, but there's an asterisk? The TLOG that is the leader, it is going to behave exactly as a near real time. It is going to update the index, okay? So if you have a set of TLOG replicas, one is going to be the leader, and that leader is going to be indexing, and all the others are going to be replicating from that leader. And then the pool replicas, they don't write the index, they don't write the transaction log, they don't receive every update, and they replicate periodically. So to show the data flow a little bit better, when a document is sent, it will be put in the index and the transaction log of the leader. See that leader is a TLOG replica, but it behaves like a near real time right now. It will go to all the transaction logs of all the TLOG replicas of the shard, and then the index is going to be replicated to all the transaction log and all the pool replicas. So, and now let's go through a summary of what the replica types can and cannot do. So near real time, again, the same type that exists, supports near real time, supports real time get, can become a leader, and can go into the leader initiated recovery state. TLOG replica does not support soft commits, does not support real time get. Again, there's an asterisk there. They can become a leader, and they can go to leader initiated recovery. So let's go. Why do we have that asterisk there? It doesn't support real-time get as long as you're not the leader. If you're doing a real-time get to a TLOG replica that's the leader, it's going to support real-time get, and it's going to respond. And the pool replica does not support near real-time, does not support real-time get, cannot become the leader, and cannot go to a leader-initiated recovery. Okay? Another note. So I say that pool replicas and TLOG replicas do not support real-time get. But if you're actually doing a real-time get request, it will be forwarded to the leader. So if you are doing the request, you're going to get a response, but you have to be careful because you're actually querying the leader all the time. So if you have many real-time gets, you're actually going to be hitting the leader hard. So yeah, we have all those types. Now, what do we do? So when you create a collection, you will decide what types of replica do you have, do you want to have for that collection. But not all combinations are supported or recommended. So these are the recommended configurations that you can have when you create a collection. All near real time. That's, again, whatever is there before Solar 7, right? And it's the default because if you create a collection and you don't specify any different parameter than what you specified in Solar 6 or before, you're going to get with a collection that's all near real time. And you would use this type, this combination, sorry, when you need near real time and when the cluster is not too big, like from small to medium is perfect, then if the update throughput is not too high. So the other combination is all T-log replicas. This combination works because one of the T-log replicas is going to be a leader, and it's going to behave like a near real time, but you just create it as a T-log, and then the others are going to be replicating, right? So you would use this combination when near real time is not needed, when the update throughput is high, when you have a big cluster, but you still want all the nodes in that cluster to have all the documents. So, and then there's a third recommended configuration, which is a number, whatever number you want of T-log and whatever number you want of pool replicas. And you use this configuration when you don't need near real time, when there's high update throughput, and when you prefer availability of search versus the near real time or consistency. So why is it important, these combinations? I mean, why are those the two last combinations? It's important that you use those and don't mix things. Let's go back to the example that we had before. Let's think now that node A and B are T-log nodes, are T-log replicas, sorry, and node C, it's a T-log or a pool, and it's in recovery. So what's going to happen is that, let's assume again, peer-sync fails. It will go to the leader, which is node A, and say, hey, which segments do you have? I have segment A1 and A2. OK, I need to download those. Download it. See how node B also has segment A1 and A2, because it's a pool replica, so it's replicating those segments. It's not creating them itself. So again, node C is not so reliable, went back to recovery, but now the leader is node B, OK? And there was some more indexing, so node B has added a new segment, but it still has segment A1 and A2 from before. So now, when there is a recovery from C, it will say, hey, which segments do you have? I have A1, A2, and B3. OK, I already have A1 and A2, so I don't need those. I'll just download B3. So the recovery makes it easier by having this combination. This is one of the combinations that's not recommended, that should not be used. Mix near real-time replicas with T-log or pool. Essentially, don't mix near real-time replicas with any type that exists right now. Let's go back to that example and think how it would work if the node A and node B would be near real-time. Let's say this is not even necessary to be in recovery. This is the periodic replication that happens for all the T-log or all the pool replicas. So node C is replicating from node A. So it has segment A1 and A2. B is not replicating because it's near real time. It's generating its own segments. If there is a leader change, so all the replicas that are T-log or pool will download everything. And that is a problem, right? See how, in this case, we can have multiple nodes that are pool or T-log, and they will all need to download all the index. Another type that's combination, that's not supported is going to be all pool replicas. Because as I said, pool replicas cannot become leader. So if you only have pool replicas, you have a leaderless shard, and you cannot index there. This is actually not supported. So if you try to create a collection or a shard and you only specify pool replicas, it's going to fail. Okay, so back to the title of my talk, I guess. So as I was saying, it's kind of easy to understand how now you can use an architecture like master-slave with the new replica types. You just need to have a tlog node that's the leader, and then send the updates to it, and then have a set of pool replicas, and then send the queries to the pool replicas, right? But you can do even better, because in this case, you got the master-slave, but you also got the problems that master-slave has, which is if that node goes down, everything, updates will not work. Now you can have a set of tlog replicas. In this case, if the leader goes down, there's going to be a leader election, right? Another node, tlog replica, is going to become the leader, and the pool replicas are not even, they just continue replicating periodically. Queries will not be affected, right? So it gives you most of the benefits that master-slave give you, which is you can separate responsibilities again. You can say updates, this node is going to handle updates, and these nodes are going to handle queries, and not mix them, not mix that responsibility. But you still get most of the benefits from SolrCloud. You can have high availability of writes, load balancing of query, collections API, node discovery, and all the things, most of the things that you would get from SolrCloud cluster, right? And this will still work for multiple collections or multiple shards. The one thing is that if you want JVM to only have masters, like leaders or indexers or masters, then you will need to use the AutoScaling replicas so that replicas of certain type go to certain nodes, and replicas of certain other type go to other nodes. And that's something that's supported too. So how do you use replica types? It's very easy, actually. So when you create a collection or create a shard, you're going to say which type of replicas you want to add to that collection or shard, right? If you don't want to use this and you still want to use the API of Solr 6, you can. You can specify a replication factor, and that's going to be translated directly to a set of near real-time replicas, right? Which is what you were getting before. And when you add a replica, you can choose which type you want it to be. And again, if you don't specify a type, it's going to be near real time. There's also a V2 option, a V2 API. There's also a SoloJ integration. They just added the parameters there. In the first example, so the parameters, the numbers at the end are number of shards, and then number of near real-time replicas, number of tlog replicas, and number of pool replicas. There's Javadoc for that. And in the second example is adding a replica, and you can choose which type you want it to be. As I was saying, like, you can use AutoScaling policies to define where certain types of replica will go and where certain other types will go, in case you need to do this master-slave separation or indexer, querier, or whatever you want to call them. There's also how do I identify which type of replica it is once it's created? For now, the way to do it is by going to the cluster state. Each replica will have the type it is. And there's also a minor, but I think it's very useful detail. See how the core name now includes the name. In this case, it's a T. So that T stands for tlog. And then if you have a near real time, you have an N. And if you have a pool, you have a P. And why do I think this is useful? Because in Solr, most of the logs include the core name. So you can now, when you're reading the logs, you are debugging something, you can understand what's going on. And you can see immediately in the log line, okay, this type of replica is a tlog. That's why it's doing replication, right? What's next? I think there's a lot of things that can be added, lots of improvements, new features. I think the replica types is like a framework where new things can be added. For now, these are the JIRAs that we have open, or the tasks that we have to do. The first one is, how old is my data? So as I said in the previous line, some slides we have before, when the pool replica cannot talk with the master for whatever reason, it's going to continue serving traffic. Sorry. But for how long, right? For how long that's enough? That's okay, sorry. So we have a this, for now, you cannot tell with the code that's currently in 7, but I don't know, there's options. So there's this JIRA open. One idea is that the response will include the time of the last successful replication, and then the client can decide, okay, do I take it, or do I do another query to some other node? Or another option is to say, hey, if you fail X number of replications, just go to recovery, the same way that you would do when we leader initiated recovery, right? I don't know, there's other options that we can take for knowing how all this, the data that you're getting, and to know how to react to that. So I mentioned that you could have master slave, and that you could send the updates to the leader and the queries to all the pool replicas. That's not fully supported yet, because the updates will go to the leader, especially when you're using the SolrCloud client. But if you use SolrCloud client, there's still no way to filter where to query. So you could be still querying the leaders, which is something that you don't want, right? So now the options are either you use like an HTTP request and you know which nodes you hit. But there's also this open JIRA that I think is going to solve this. And there's a patch already. I mean, that doesn't solve the replica type side, but it does solve a similar problem, and it's giving us the opportunity to build on top of that for adding this feature very easily. Another improvement that we could do is that the replication doesn't always need to be from the leader, right? So if I go back here, I say, yeah, pool replicas replicate from that cluster of T-log replicas. Right now, they all replicate from the leader, and that can be a bottleneck. If you are okay with being a bit more behind, right? Because the T-log replicas are also replicating. So you could replicate from any of those, as long as you're okay with being a bit more behind, because you have to wait until that T-log replica replicates, and then you will be replicating from that one. Sorry. There's still absolutely no integration with the UI. So as I said, the only way right now to know which type of replica is by going and looking at the cluster state. And yeah, it would be better if we had some integration to the UI. There's also no integration with the CLI. So if you're using Bean Solar to create your collections, you currently cannot use replica types. Yeah, and then I guess there's more features like bandwidth limiting, a bandwidth limiter for the replication, or I don't know, other replica types like HDFS, or I don't know, whatever people want to build. Patches welcome. So yeah, these are the JIRAs that I think these are the main JIRAs where the code for replica types is. You can go take a look, have like a reference, and that's my talk. Thank you. Yeah.
Question about search availability on the T-log replica.
Uh-huh.
The T-log replica goes down and then comes back. We will continue to serve query.
The T-log replica. Okay, so the question is if the T-log replica goes down and it comes back, it will go to the same. So the T-log replica will go to the same recovery process that will do any near real-time replica. The pool replica, if it disconnects from Zookeeper, then it will also do that. So if the pool replica is completely out and it's disconnected from Zookeeper, when it goes back, it's going to do recovery, because you don't want to be serving weeks of old data, right?
Okay, so
Yes, yes. Well, while it's in recovery, it's going to be offline. Yes.
Is that geoticket to deal with this, like how old the database?
So the Jira for, sorry, the question is if this. So the Jira is for I mean, it's still like in design phase. So what option do we take? We can even take more than one. I think that the idea right now is to make it so that we can know how old is the data. But in that case, what you were talking about of a replica going down and then coming up is going to go through recovery in any case. So it's not going to be serving traffic until it's active. Yeah.
Can we change the type of existing replica in the live cluster?
So the question is, can we change the type of a replica in a cluster? And the answer is no. There's no way right now to do that. The only change, it's again, it's not actually changing the type, but a T-log, when it becomes a leader, is going to behave like a near real time. But again, it's like it's still a T-log replica if you look at the cluster state.
So it'll accept soft commands?
Sorry?
So will it accept soft commands?
So the question is, will the leader accept soft commits? I think it would. The problem is that it's not the same as real-time get. So with real-time get, when you're doing a query to a specific, you're doing a specific type of query, right? You're doing a get query. So we know in that case that you want a get request, you want to get the latest document, and you want to go to the leader. In the near real time, let's say we only do near real time on the leader, how do you know that a query needs to be served with near real time data versus older data or something like that, right? You could do a soft commit and then go do a query directly to the leader, and that would work. But that's not like something I would say it's supported. It could be an improvement.
To make sure you're separating your queries from.
Yeah, yeah, yeah. I think he was first. Yeah, sorry.
So, I mean, in this current structure, the indexing responsibility is more the T-log leader, and the other replica is just pulling stuff. So, I'm wondering, like, since the pull replica is trying to do a lot of work, like, what is the performance implication that you guys saw in terms of response time and just general availability of the cluster?
Okay, the question is, what's the performance implication that I don't have a metrics for now here to show. Sorry. Yep.
Pull replica, when it, just to clarify, does it pull the segments that it needs, or does it copy the whole index?
No, it's incremental, so it will only pull the segments that it needs. Okay. That's the case, and that's why it needs the leader needs to be a T-log, right? Because then the same segments are shared across all the cluster, instead of each replica having its own segment versions or whatever.
Okay, and I suppose it's the same question you were asking there, in the pull from where it's pulling from.
The leader.
We find when we do this, it's where you're reading from, it's where we get the bottleneck, not where we're writing to.
Yeah, so the comment was, is there a bottleneck in the leader because everyone is trying to pull from it? Yeah, there could be. That's one of the improvements that we could have, is to be able to replicate from any of the T-log replicas. Which, by the way, it's like you would have, that's kind of what you would have in master slave. With this, you can do better, right? If we can do the replication from any T-log, then we are solving that problem that in master slave existed, right? Also, yeah.
I don't think this is an issue, but from what you described, but is there anything around the cross data center replication that's implied?
I don't know. I haven't used the cross data center replication. I don't think it would be an issue, but I don't know for sure. Sorry. Yep.
So, during query time, so is there a preference given to the pull replica versus the T-log replica? Like, is there something you guys thinking about?
Right now, there's not. But yes, I mean, that's what I was saying. We could have that integrated on the client side, on the SolrCloud client, so that it tries to go to the pull replicas first. We don't have any more time, so thank you very much. Yeah, if you have any more questions, come to me.